I've started recording.
Good morning, participants, and good evening to Aman and David and other people from the other side of the planet. So I am Dr. Shobha, Professor of Computer Science and Engineering, Data Science, RV College of Engineering, Bangalore, India. So it is my pleasure to welcome you all and just give a glimpse of the background. So on what is the purpose of conducting this particular workshop. So before that, I just wanted to talk about the collaboration and what RVCE is and what HPCC is. So RVCE is a technical institution at Bangalore in India, and it is ranked 89th in the country by National Institute Ranking Framework. It is accredited by NAC and NBA. It offers 13 bachelor and 16 master's program and doctoral studies, and all the department have research centers affiliated to Visvesvaraya Technological University, Belagavi. The institution has filed 32 patents since last year's, of which 22 patents have been published. And the college has 21 centers of excellence with a focus on interdisciplinary research. And we are happy to collaborate with HPCC system from past 5 years. And HPCC systems from LexisNexis solution is a proven open source solution for big data insights, and that can be implemented by businesses of all sizes. So with this collaboration, we have established Center of Excellence, and the activities undertaken by this center includes consultancy, research and development, and publishing patents, and internship and training program to the students as well as faculties and industry personnel. So basically RVCE has collaborated with HPCC systems to leverage HPCC system for data science, that is big data analytics problem. So today it gives me an immense pleasure to organize the 2 days workshop on NLP Plus, the programming language for natural language, with my organizers, Dr. Jyoti Shetty and Dr. Vishalakshi Prabhu. And it will be delivered by the resource person, David and Amnon. So just to introduce David, so David has over 30 years of experience, and he is a consulting software engineer for LexisNexis. Currently, he is a part of HPCC System Supercomputing. Before joining the company, David worked as an engineer or a scientist for text analysis at McDonnell Douglas and Battle Memorial Institute, where he developed practical NLP toolkits and systems. David holds a bachelor's degree in mathematics and a master's degree in linguistics from Ohio State University. He is an architect of VisualText and co-architect of the language NLP Plus, and he is responsible for creating the VisualText open source project, the port of VisualText to VS Code, and creating NLP engine, which runs on Windows, Mac, and Linux. He is also a scientist, artist, and a musician who has his own YouTube channel and has published a book on a new model for the universe with his father. So we are proud to have you here, David, and I welcome you.
Thank you.
Yeah. So we have one more resource person, Amnon. He has more than 3 decades of cutting-edge experience in the area of natural language processing, leading the creation of innovation system and approaches in aerospace and in universities. He is a creator of NLP Plus and the conceptual grammar, which are the 2 components of NLP engine. His education goes like this. He has MS Computer Science from US Berkeley, MS Organic Chemistry from US Berkeley, BS Biology MIT, 11 years in aerospace, NLP R&D, that is McDonnell Douglas and TRW, 5 years of UC Irvine AI Lab and DARPA Navy projects. He is currently CTO of Conceptual System LLC, California, and he has participated in the open source project NLP Plus, VisualText, and Conceptual Grammar. It gives me an honor to welcome you, Amnon.
Thank you.
So welcome, David and Amnon, and this gives an opportunity to welcome all the participants for this workshop. Thank you, and over to David.
Okay, I'll go ahead and I will share my screen here. Let me know when you guys are seeing it.
I can see it.
Are you seeing the right screen? Are you seeing the entire screen there? Not my.
It looks small.
Okay, let me try one more time. Make sure I get the screen 2. There we go. I got it. Sorry about that. You were seeing my screen. That should be a little bit better.
Yes, better.
Okay, sorry about that. Okay, let's get going. Whoops, it's changing on its own. I'm David D. Hilster. I'm with the HPC Systems Supercomputing Group, and today we're going to be talking about intelligent programming using HPC Systems and NLP++. I'm with my colleague Amnon Meyers. As she said, I've been 7 years here working with the Supercomputing Group. I have 35 years of practical NLP experience, currently working on an NLP plus plugin and bundle for HPC systems, and some real applications of the technology at LexisNexis. I'm co-author of the computer language NLP++ and creator of VisualText. Oops, and sorry, just decided to move on its own here fast. Amnon Meyers, of course, as he said, is the CTO of Conceptual Systems, 35 years in NLP, and of course, working on the open source project and creator of the conceptual grammar and co-author of NLP++. So what we're going to do today in these workshops, we're going to give you a brief history of NLP and NLP++, because a lot of people are not aware of how it would fit in, how NLP++ fits into the world of programming and why it's really become very popular right now. The NLP++ language, which Amnon will talk a lot more extensively about, and also the conceptual grammar knowledge base. And day 2, it's wanting, sorry folks, it's trying to move on its own here. Day 2, we will be, I'll be showing you a real world example of NLP++ and walking through that and analyzer walkthrough.
You should be able to pause it, David. Right click and pause.
Okay. Yeah, and so again, tomorrow we'll have a real world examples on NLP Plus and an analyzer walkthrough. So that we'll be doing tomorrow. I put this together what I can see as a linguist, what I now call the 5 linguistic revolutions. First, there was language 70,000 years ago. There was writing 3,400 BC. There was, of course, the printing press, which then was a big revolution in linguistically, where we got knowledge everywhere. The system of language by Noam Chomsky. We'll talk a little bit about that in the 1960s, where he demonstrated that language had rules. And then what I'm seeing is, starting last year, really the transfer of linguistic and world knowledge to computers. And one of the things we have to understand is that today's orthographic systems, which is a linguistic way of saying our writing systems, are completely arbitrary. That is, the symbols we use are arbitrary. If you are not taught these things, you will never know what these are. Meaning must be learned and memorized, and we must give this meaning to computers. Now, this is, of course, a little different from machine learning. And one of the examples of why that this is really true is hieroglyphics, which started around 3100 BC. People, the best minds in the world for 1500 years could not figure it out. And again, this is kind of comparing machine learning. If you were to give this computer hieroglyphics, they will have no way of understanding it either, because again, symbols are arbitrary. And until we got the Rosetta Stone, where we knew some of the symbols already, we couldn't decipher it. So that gives you an example. Again, just looking at having a computer look at massive amounts of text with no context or no meaning, they aren't going to produce meaning. So intelligence, we're claiming as well that it requires language. Language and intelligence have evolved together over thousands of years. Knowledge, language, intelligence almost is really inseparable. Just try to think of today's world. What would it be possible without language? And intelligence requires understanding language and the world it represents. The purpose of language is I've got something in my head.
David, can you try shutting your video? Your voice is
breaking. Okay. Let me see if I can do that here.
Down below, there's a share video button. Down at the bottom of the WebEx.
Let's see. Don't mirror my video settings.
No. At the bottom of the WebEx.
I know, but I see a different thing because I'm presenting.
Okay.
So hold on. I'm going to stop the presentation right now. I will get rid of stop my video.
There you go.
There we go. And I'll share again. Sorry about that, folks. All right. That should be better. Okay. Again, a language is we have something in our head. We transmit that information via a language, a natural language, which we have to understand how that works. And then hopefully the idea is to recreate something in your head. NLP++ is really looking at these kinds of things, the concepts of these things, not the specific language necessarily. Human language, again, it has to be learned. We have the best neural network in the universe that we know of in our heads, but if we don't teach language, it's not learned. It takes 4 years for English, the easiest language to learn, 14 years for a language like Finnish. And so again, we need to teach this to computers. And I thought long and hard about this question: what is traditional programming versus programming in NLP++, which is quite a shift in programming. Well, in traditional programming, you think like a computer. All the people probably watching this are computer programmers. And when you're a computer programmer, what makes you an expert is you know a language like Java, SQL, Python, C++, C, TypeScript, and you have the ability, when given a task that you want a computer to do, to think like a computer and program like a computer. Well, that's very different from intelligent programming, because you have to think like a human. Now, that's not easy. I've had over a dozen interns from high school all the way to PhD level in colleges, and this is the hardest problem. It is a paradigm shift, truly is. And it reminds me of the Fight Rule, Fight Club. It's an old movie, and they had rules of Fight Club. And the first rule is you do not talk about Fight Club, and the second is you do not talk about Fight Club. It's kind of humorous, but it means it's very important. It's so important you need it to be the first two rules. Well, in NLP++ programming, you need the first rule is think like a human, and the second rule is think like a human. It's very, very important. So intelligent programming, for the first time in computer science, we can have computer programming language that encompasses intelligent programs. That's using NLP++, the conceptual grammar, which I call kind of the brain, and VisualText, the IDE to build all this. It's an open source technology, runs on all 3 platforms, and one of the people who worked on the original team for developing this came up with this slogan or theme, and anything thinkable. If you can think about it, you can program it. Just a background of myself, of course, you learned, we both met in 1990 in an AI group and worked together since then. So we worked together over 30 years. We participated in DARPA message understanding conferences, placed 3rd in only 3 months, kind of as a precursor of NLP++. The technology itself was developed of the Amnon Meyers family startup in 1998. And by the time 2001 rolled around, we had then NLP++, the conceptual grammar and VisualText. Unfortunately, we launched during the dot-com crash. A lot of you people weren't born then, but if you want to look up the dot-com crash, you'll find out that people were throwing money at just domain names, having no idea how to use the internet, and the entire thing came crashing down. And at that point, you see this bubble here, which is I unfortunately was right. It'll take 20 years for the industry to keep up with this, but it was used by IBM, NASDAQ, ETS. We went to the cloud in 2013 and had customers there. I joined LexisNexis in 2015. In the end of 2018, it went open source. And then today, in 2022, it really started to gain momentum. People really were starting to look at it. So again, open source 2018, VisualText, NLP++. And the 3 components, again, are NLP++, conceptual grammar, and the IDE. We use a lot of file extensions. The .NLP was not taken, and that has been taken now by NLP++. It is so a .NLP file. Used to be called PAT for patterns. It's now NLP. We have a tree file, which gives you the syntactic tree. We have KB files for the knowledge base, dictionary files. We'll talk a little bit about those. Why has it become so interesting to the community now? It's because machine learning for the last 20 years has been doing some amazing stuff. It really has. But it's now being recognized as insufficient for a lot of NLP tasks. The NLP solutions have an accuracy ceiling. one of the biggest downfalls truly is actually for NLP is it requires massive numbers of human-generated examples. A lot of times you can't get those that massive of amount to develop on, and contrasted with NLP++, which only needs a small amount of text to develop. The reason is human brains can generalize, so we don't need a whole lot of examples to get ourselves going. And machine learning can never understand meaning. Just like hieroglyphics, you can't have it look at trillions of symbols of text in Chinese and ever come back with the conclusion that this symbol means mother. It won't do it. We have to teach it. So the idea that machine learning will learn this by itself, it's not going to happen. And so machine learning typically does not use knowledge. And the recognition, and now we're starting to see actually 2 papers being written on it, with the third coming. Shobha and her group are looking to write a paper on NLP++ as a paradigm shift in programming, and it allows us to do things really previously thought to be impossible. They're going to be comparing it NLP++ to a program like Python to see how those things compare and the advantage of NLP++. At Clemson University, we have an assistant professor who came to us and wanted to write a paper. She has a PhD in machine learning and NLP, and she was writing that paper saying that machine learning is over applied and that NLP++ and knowledge-based systems are really needed for this. And so you can see that's really why people are coming toward us, is because machine learning is trying to be over applied to places where you really need knowledge-based systems. And so this is why all of a sudden it becomes popular. It is a paradigm shift in programming. It really is. Like I said, the biggest problem I have with interns is that they are not thinking like, they're thinking like computer programming language and not like people. So in what we're looking at is text. Text has structure. We know that. There's knowledge, for instance, the human body knowledge, there's dictionaries. If you look at a traditional programming language like Python, you have all these things you kind of glue together. I've got my speech recognition over here, or my part of speech tagger. I have deep learning in neural networks over here. I have a text to try to get to the text owner, ontology. There's no custom syntactic tree that you really can build. There's no live knowledge base you can build. There's no standard for the knowledge base, and communication between these pieces almost doesn't exist. So in natural NLP++, all of it's integrated within the same language: syntactic tree, the knowledge base, linguistic and world knowledge, and all the levels can pass information to all levels, which is really important because you don't have this kind of siloed, opaque packages. One of the big problems in the traditional knowledge-based system is that they use syntactic rules for natural languages. A prologue invented in, I think, the early 1970s, where you could just write the rules, these syntactic rules, like a compiler for a computer language, and prologue parses text with it. The problem is it is top-down, which is fine, but it quickly got into combinatoric problems, and you would have many variations of the tree. You wouldn't know which variation, could have as many as 100 variations for long sentences, and it would just take forever. The combinatorics just didn't make sense. So NLP++ usurps those problems because it's a bottom-up, island-driven. You tokenize the text. You then have a multi-pass. Each pass runs through the entire text, and you start with the smallest units. You get things like these things, money, for instance, 3K. You build these and you build up larger and larger phrases. It's not only much faster, but it also is easier for we humans to process text, because doing trees in our heads and trying to use trees to parse things is just really impossible for us to develop. It eliminates, of course, the combinatoric explosion, supports any type of NLP++. You can do you can do top-down. If you want to do top-down like Chomsky, you can program in NLP++. You can integrate multiple paradigms like machine learning, part-speech taggers. It can use it all. The reason we like NLP++ to do most everything we can is because it's 100%, glass box. All the code is there. There are NLP files. I'll talk a little bit about the files. The .NLP files, there's 3 regions or 3 types of files. There's code, where you can just write pure NLP++ code. There are declaration. We have a declaration area where you can write your own functions. And then, of course, we have the rule and pattern matching, and it is the most sophisticated rule system in the world. If you hate regex, you should learn NLP++. Once you learn it, you will use it as a programmer, even if you never do NLP++, because it's so good at taking in these text files and organizing them, doing lots of things with them very quickly. Of course, there's NLP++ functions. There are tree functions. They're called parse node functions, or KB, or knowledge-based functions, string functions. Of course, you can write your own functions. There's a dictionary file, which is quite new. It allows you to write dictionary knowledge quite easily. Excuse me. You can have a word and its attributes, and it comes, and then when you parse it into the tree, this is the parse tree. This is what it looks like. So you put a word there, an attribute with it. Maybe it's the word 7 written out. You'd have a numeric equals the value of 7. Again, you can make these dictionary files very easily, either by hand or produce them with an NLP++ parser. You can also have it actually almost write rules, so that if you have a word, you want to look it up, and you want to put it underneath a concept right away and give it attributes, you can. And you can even do phrases. So if you want to have phrasal lookup, so this is a kind of a shorthand way to do build a tree right away in a dictionary lookup. We have a already standard with NLP++ English, a full English dictionary. Speech, if you want only pronouns. We have numbers, as you can see over here, so that's already there. So if you want to have that already in your system, we have stop words, in English, Portuguese, Spanish, all those kinds of things. And we'll be growing this constantly. This is just brand new, and we hope that people like yourselves who are interested in this technology can help grow these dictionaries. We do have a dictionary project, what I call Global Worldwide Dictionary Projects. We're looking at the Wiktionary project. Dr. Shoba's students are working on an English parsing the English dictionary to get parts of speech. The idea is that we will be really the place where you're going to find real linguistic knowledge-based dictionaries that we can use for processing text. And they're working on that right now. I've started Portuguese. Tamil it looks like it may be an interim project for summer of 2023 in the HPC systems. We did Chinese last year. We found that Wiktionary was actually useless for natural language processing for Chinese, because it was only there really to teach people the meaning of the words and how to write them. And they don't even have parts of speech. So we are looking for alternatives. We found some alternatives to that. And Nepali, there was a Wiktionary initiative where they only have 16,000 words, and that was a project from Clemson. Other dictionaries, of course, addresses for all languages, street names, human names, medical, legal, emoji attributes for sentiment. The .kbb file, it's a KB file. It's the newer KB file. I call it KB Beautiful file, which is easy to read and build. It's a hierarchical knowledge base. You can just see it's a hierarchy. You just indent it, and this is the parent, and this is the child, and then their grandchildren, etc. You can give it attributes. You can also do attributes with strings. You can point to other concepts. So this is what makes it powerful as well. You can point to concepts in the conceptual grammar or knowledge base can point to other places in the conceptual grammar. So you can really pretty much represent anything in human knowledge in this if you have enough time and space. The building options is as you are running an analyzer in NLP++, you can dump it from memory, you can build it by hand, or you can build it directly into a file using an NLP++ analyzer. Proposed knowledge base, we don't have any right now, but we have a placeholder for that, the human body. We could have things for medical codes, resumes, legal, real estate, whatever. And as time goes on over the next decade, we hope, because NLP++, we think will become more ubiquitous and people will building these things, they'll be available and people allow them in the open source project to be available. But we're in the beginnings of this new technology. It also deals with emojis in Unicode, and they're treated as normal characters. Yep, here's a rule, a syntactic linguistic rule that says this emoji and that emoji. If you find that, write it under the concept of this emoji. Again, using it. Here's a Chinese characters with rules just showing we can do that. We do have a sentiment analyzer that's being written by a university student in Brazil. I think it's like the 6th best university in the best university in Brazil, so quite bright young man, has written a sentiment analyzer, and he's using NLP and emojis and writing rules with that and dictionaries. So that's quite powerful. The typical steps with NLP writing a program is you deal with formatting, that you want to find the text when you break it down into an organized tree. Maybe it's a resume, maybe it's news articles, maybe it's sentences. You have a knowledge that's needed for the text. You need some dictionaries, you need some knowledge bases. It's very common, very, very common to write multiple NLP analyzers, one to study the corpus and the vocabulary. You just write code. It's just too fast and too easy to not use. And you can look at the vocabulary. You can build knowledge bases from or database sources. You can build knowledge from text or database sources and use it in the final analyzer. You can organize the text you're processing. Oftentimes texts come to you and it's just all I really need is this code and the text, and then we'll use another analyzer for that. You can also, of course, process the text. That's the last thing you do is, what attributes do you need to keep in the tree as you're processing this text? You're reading, you're analyzing, you're parsing this text. And you can optionally build a knowledge base as you do that. It's very common that we do that. The formatting, what do? You break things down into letters, numbers, punctuations, emojis, Unicode. You build the smallest pieces first, like emails, phone numbers that require spaces, no spaces, so you get those done. You have rules after the spaces that make things easier. You can either do that with the tokenize, or you can remove them by hand. We have special passes for those. There's special tokenizers for removing white space, adding attributes from the KB in the dictionary. Is it line oriented? Very important. There are a lot of texts that are line oriented, so you want to look at lines. For instance, headers. Headers occur in a line. If not, you have paragraphs and sentences and bullets. And we have this X-out analyzer. It's just quite new. We're working on a resume analyzer at LexisNexis with an intern in India. It happens to be LexisNexis India. And this is what it does. It makes you aware that when we humans read text, we also look at formatting. It's not just words and their meaning. If you look at these, this is what the X-out analyzer, it takes any text that you give it and changes all the text, no matter what language, into X's. And it forces you to look at something we humans do. When a human looks over a document, this is one of the first things they do. And we forget that humans not only read text, we parse the organization. Here it looks like, this looks like a news article. Oh, I see this up here, and this is a paragraph. The next paragraph is, in fact, is a news article. What does this look like? That looks like, 2 words, emails, a header here, a list here. You don't have to know anything about the text. You can do an awful lot with NLP++ just by knowing formatting. The knowledge base, you have a knowledge base and output as part of your processing. You may pre-process things that you may have come in CVS files, database files, text, HTML from a web page, and do that often. I need to have all of the human languages, the most common for resume processing. What do people speak? The top 100 languages. I go to a web page, grab it, throw it into the visual text, parse it, put it into a knowledge base, and here now wham! I got all the spoken languages and information, and that becomes a knowledge base which will be available to everybody. What are your output requirements? Are you going to output just simply text? Are you going to output a similar text? You got a tag. We did something that would take 700 hours in 2 days. I wrote something that would take a human 700 hours. That was to go through text for our documentation for HPCC and ECL and mark those places we didn't want translated. It was deemed an impossible task. I did it in 2 days. Knowledge base. You may end up with a knowledge base. That's what you want, or a dictionary, or XML. This is what we use when we call NLP++ analyzers in HPC systems. Come back in XML, and we put it right into the database. The part that I developed was NLP, that was called VisualText, is very important. More than 50% of our core text is dedicated to vision. Why? We are visual people. Neural nets are great at visual recognition. It's the way to go. You don't want to write knowledge-based systems for this. Speech recognition, speech to text. We are very good. We hear stuff and we can parse that. Very good with neural networks. Neural networks are bad at mathematics and language, exactly like humans. Humans have to be taught mathematics. It's not something easy. And everybody says math is hard because neural networks aren't good at those things. Language, neural networks in the beginning are not good at those things. It takes 4 to 14 years to learn. So NLP programmers need visualization tools. They just need them. And that's what VisualText is. Else dictionaries, knowledge base, and analyzers can be overwhelming. How do you go with a tree? You've got a tree, a text tree of the entire article. You're going to go in and no, you need to be able to visualize it, search it, and look at it. VisualText is a vital part. Without it, we really couldn't do NLP processing the way we do. And the number one comment from NLP programmers, my students, is VisualText allows us to see what's going on. So let's take a look at the visual VS Code NLP Plus language extension. That's what our current version is. Let's take a look at some of the history. VisualText was first written as a Windows-only IDE written in C++ using Visual Studio. It's still available, versions 1 and 2. I think version 2 works only somewhat, but version 1 still works. Amnon still uses it. But the newer version is the NLP language extension for VS Code. Of course, there's a couple of things. One, it runs on all platforms. And believe it or not, the biggest complaint I got about VisualText was it didn't run in dark mode. Of course, I'm an older programmer and I just don't care. But people like that. It's easier on the eye and expect it. So now, of course, with the VS Code plugin, it goes in dark mode, light mode, but almost everybody's in dark mode now. The first version came out in December of 2020, and the version 2, which is a big improvement, came out. I worked over my Christmas break, holiday, and the holiday breaks in 2022 came out, and that's when we introduced the KB Viewer, dictionary files, and the KBB files. And of course, we also have Unicode and Emoji, which really wasn't part of the past system. This is the typical interface. I drew these lines here because you can rearrange it. I like to have it vertical because with text and things you have it vertical. But on one side, here's the NLP Plus in the activities tab here. You click on that and you'll get your text browser here where you can run your text. You can run your analyzer either on a folder of text or text itself. Here's the analyzer sequence, which is just one sequence after another. It runs the code each pass. A knowledge base and dictionary viewer, that's brand new. Here's over here you have the output files for the analyzer. Output files are only when you run for one text. They're not across text if you're running on lots of text. You have the analyzers, which is very important because you're often dealing and working with several analyzers at a time. And then you can click on and you can move things from one analyzer. I'll have an analyzer that'll build some knowledge base, and I can quickly move it by right-clicking here, move it to my other analyzer, use it there. So this is very important. And we have a logging, so you can see what's going on. If there's updates, you'll see the updates going on there. And you can see the timings. It's very important. So if you have an analyzer and it's taking a lot of time in a recursive pass, you don't know why, you can look at the text over here. And then, of course, you can do searches. But you can use all the VS Code functions. For instance, control / will comment anything these. And here you have a knowledge base display, a dump of a knowledge base here. Here's a tree. Again, they're all text. This is a .tree file. This is the .kbb file. And this is a .nlp file. And here's a .txxt file, which if you click on any of these, we'll see this tomorrow, you'll be able to see what you're matching. So very visual. Without it, believe me, you can prototype real fast with this. It's a vital part in program NLP because, again, we're visual. We're not, our brains are much more visual. We can take a look here a little bit more closely. Here's a rule in NLP which says if you have a money concept followed by the preposition in by a money type, you will make that into a concept itself, and you can see this will build this part of the tree. It takes these, puts them under tree, and then you can do some things. You can put values on them. You can take the text and put it here. You can put the value of the number and put it here as well, and you'll see that we have a reference back. So if you're looking at the tree and you go, what rule filed that? You right-click, say, give me the rule filed, and it comes right back that. Why does it know it? Well, it has these numbers. Pass 15, line 17. That's what this tree has. So again, everything's transparent. Here are some of the values. So as you're building trees, the power of NLP plus is you can build trees any way you want, and you can put any attributes you want. Here's the value of 14.3 million. There's the value. It's a type is assumed debt. I can put all that on there. It's very important to be able to do that. Very powerful. I can also point to concepts. So if I have a sentence and I'm going to build in my brain, I'm going to keep like a pad. I think of the conceptual grammar as a pad and paper, pencil and pad right next to your computer. And as you're reading something, you make notes about it. You keep track of what you've read. Well, here I'll build a concept for every sentence and keep track of what I find in it. Well, in the tree, I can create that object and a sentence. This is a pointer to sentence 2 in the brain, and so I have that available. So if I find an officer, I can go to the brain and say, hey sentence, where are you pointing in my brain as the place where I'm trying to remember it, and write it into the brain. And that's what this is. You'll see this is the KB it was pointing to. There's sentence 2. There's here's the TAI and the CEO. So I can build knowledge as I read the text. Extremely powerful. And it's 100%, you do it the way you want. One of the things that is really hard, we've had many people come to us, I can't do an Afro. What's an Afro? Well, you say the word they, or it, or it's. What does it refer to? Well, here's a sentence from Avi Meyers, CEO, president of TAI, said on Friday that they, well, what's they? Well, we know when we look back, it's going to be TAI. Well, that's, for us, it's easy to do. NLP++ is easy to do too. This is a printout of us doing an Afro. And what do? This is it. All you do is find the word in Afro, have a dictionary of all the words like they, it's. Then it loops through the knowledge base of all the things we're keeping track of. Remember, we're keeping track in this analyzer of what we've read in our brain. And in our brain, we keep every sentence and what we find. So we go back and look for an object. The first object we find, that's what we get when we print it out. This is all the code. One of the hardest problems in all of linguistics and natural language processing. It's done. Yeah, it's not, we don't check the gender and all that, but you can see it's very easy to do. So the overall picture is NLP++ makes tree traversing and manipulation. We have all those kinds of functions visually. It's just really easy to use. The knowledge base building and traversing functions we have for doing that. You can write your own functions. We have the TDB files for easily building knowledge and dictionaries, and of course, VisualText. It's just an ideal environment for building knowledge that we can share. All this can be built and shared by all of us, and it's 100% code. You're not using a black box from Stanford that does part of speech tagging. It's doing it wrong. Now you have to change it. What can you do? So we do have tutorials I've made working with students. I've made a set of tutorials which come with, if you go to the analyzer pass, when you download it into VS Code, there's a little, I don't have it shown here, there's a little cog. You click on that and you'll get all of these tutorials and everything that come with it. And you click on that, and each one has a README file. There's a little icon there, and it'll tell you each one, and you have a link to a tutorial video that I've created. Now I'm going to turn it over to Amnon. Amnon, I'll just keep doing the slides, you let me know. And he's going to really talk, what is NLP++? What is that? So Amnon, if you want to go ahead and take over.
Yes, hello. Let me know if you can hear me well.
Yes, you're good.
Sometimes we're glitching out. So yeah, David has talked about a lot of the new things, the new version of the Visual interface and Visual Studio Code, and some runs all three forms, Windows, Macintosh, and Linux. I'm going back more to basics here, telling you in more detail what NLP++ is, and what its advantages are over previous methods for natural language processing. So, so NLP++ really is a general programming language, and it's modeled on C and C++, but it has augmentations for natural language processing. And basically, it builds multipass analyzers analogously to the C system called Yak, Antler, Bison, those kinds of multipass grammar, systems that deal with grammars and writing code actions when grammar rules match. The variables in NLP++ are act like normal variables, but they also address the various contexts that you need for language analysis. So they deal with the effects of parse trees, as well as components of knowledge bases, as well as the context that you have in your rule files, and in the grammar, the rewrite rules themselves. So variables address the elements and suggested node of a rewrite rule. They address the components, the elements of the knowledge base. And one thing that's different about NLP excuse me, from other languages is one of the big differences you'll see is the way variables are written. In most languages, variables are just a alphanumeric string. In NLP++, a variable is written as a letter, a capitalized letter, parentheses, and then the variable name in quotes. And the reason for that, again, is because the variables address all these different contexts within grammar rules, within the knowledge base, within the rules files themselves. So the bottom line, NLP+ is a general programming language augmented to manage a parse tree, a knowledge base, and rewrite rules. Basically everything you need for the text analyzers that you build within VisualText. David, next slide, please.
Yep, there you are.
So this is taken from the old textanalysis.com website, basically a table of features and benefits. And I've starred the particular benefits of the NLP++ language itself. So the first star, NLP++ integrates code, rules, parse trees, and knowledge bases. And NLP++ manages multi-pass text analyzers to avoid any combinatorial explosion. The NLP++ analyzers build and elaborate a single parse tree. So the multiple passes are all operating on the same parse tree and putting new pattern matches and attributes and so on into that parse tree. In a real sense, we're paradigm independent in that we can include other paradigms as passes, as particular individual passes within the NLP++ multi-pass system. Also, the rule matching can operate in specific contexts. For example, you can say, I want to look only within noun phrases now, or I want to look only within particular domain-specific noun phrases, as an example, and have your rules operate only in those contexts. So, next slide, please, Dave. So, there are many natural language processing pipeline architectures out there, and here what's unique NLP plus basically most other lines bring together a bunch of hardwired black boxes that are so NLP++ has a glass box aspect where you can see the code and the rules and modify the code and the rules and so on for each pass. And not only that, you can use highlighting in the VisualText development environment to see what each pass has been doing. Uniformity. So all the passes that are within our system are written in NLP++, just one language, and other pipelines typically have build black boxes that are from disparate sources and written in various programming languages or methodologies. Synergy and cooperation. So other paradigms typically degrade. In other words, if you have two passes at 90% accuracy, your resulting combined accuracy for the two passes is going to be 81% at best. So with NLP++, the passes can cooperate in a sense to improve the overall text analysis. Passes can gather information, passes can execute the high confidence actions first and provide context for subsequent passes of the multipass analyzer. So flexibility and modularity. NLP++ can be added as needed, wherever they're needed to focus on specific tasks. You have a multipass system. One of our customers called it the pancake model. So each pass is a pancake. You can insert pancakes whenever you want. Oh, if you forgot to do some kind of processing, you go and insert a new pancake or a new pass in the right place to get a previously ignored task done. So overall, NLP truly addresses the ability that everyone talks about: flexibility, modularity, uniformity, visibility, and so on. Let's see, David, you went to the next slide. Thank you. So also, as I've mentioned, there's a super extensibility aspect in that NLP++ within its own confines is highly extensible. Really, we find there's no obstacle to increased accuracy, to increased completeness, in the sense that you can always add more capabilities, you can add new methods. Whenever you reach an obstacle, you say, what's stopping me from improving this system? And you know exactly what you have, and you can add more passes or more capabilities to your passes as needed. So, and in addition, I mentioned you can add external black boxes. If you have a great part of speech tagger, you can incorporate that as a pass, as a black box pass within a multipass NLP++ analyzer. So there's a user project within each NLP analyzer that enables users to actually add C++ code. You can add NLP++ functions to the basic language by writing your own C++ code. And that code could be something to incorporate, for example, that black box or third-party part of speech tagger. And I've actually demonstrated that with the old VisualText. And I believe David has not yet incorporated this user project into the Visual Studio Code version, but that would be a worthwhile addition to the current system as well. Next slide, please. David, can you hear me?
Yes, I can. I'm sorry. I was enthralled with reading on your slides.
So David talked a little bit about the structure of an NLP pass file. Here's a little more detail. So we use @ followed by a alphabetic token to delimit the regions. Actually, if you use a double @ you can end one of these regions. So we started at the top here with a decal region, which holds the user-built NLP++ functions. Of course, there's a whole set of pre-built functions within the NLP++ language as well. The code region within a pass file executes code before rule matching. One thing to add here is a code region that operates after rule matching, but that hasn't been done yet. Following the code region is a rules section where you can have multiple instances of the regions below. So, and all these subsequent regions are concerned with rule matching, rewrite rule matching. So at the bottom is a rules region where you write your rewrite rules, and there's a left arrow. So the elements of a pattern match or a rule match are to the right of the arrow, and the suggested node would be to the left of the grammar rule arrow. And you see that under the rules section, it says pre-region, which is a kind of a special syntax for preconditions to a rule match. There's a check region where you can write NLP plus code for where you can create conditions for accepting or rejecting a rule match or otherwise acting before the rule match executes. The post region is NLP plus code that operates after a rule has matched. Next slide, please, David. So because NLP addresses contexts within standard programming language contexts as well as parse tree, rule file, and knowledge base contexts, we've got this different kind of NLP variable syntax, and there are 5 basic types. So there, as with standard languages, there's a G variable designates global variables, and you can see some examples here. gvar, so a global variable named var is set equal to 1. There are also some predefined special variable names. So $input name will get you to the name of the current input file if you're processing files. Then there's local variables which have the L letter attached to them. And one example here is actually find root is another pre-built NLP function, finds the root of the parse tree. And here you're creating a knowledge-based concept called person. I'm sorry, this is root of the knowledge base, not root of the parse tree. So under the root of the knowledge base, you're creating a concept called person and setting a local variable called con to that. The n variables address nodes in a rule match. So you have multiple elements in your rule match and one suggested concept or one suggested node. So a node variable can refer to element 1 or element 2 or element 3 of a rewrite rule. And similarly, the S variable refers to the node that's going to be built. Typically, when you match a pattern to the right-hand side of a rewrite rule, and you can actually set up the values of the suggested variable before or while it's being built. So the S variables let you put attributes on the node that represents a pattern match in a rewrite rule. And the X variables enable you to address the context that you're matching rules in. We said that NLP rules can operate in specific contexts. So here, for example, there's a path designator that we haven't discussed before. Basically, it tells you the context that you're going to match rules in. And here we're looking at underscore root, which is the root of the parse tree. Underneath that, you're going to look within paragraphs, and underneath that, you're going to look within sentences. So the X variable tells the sample here tells you that you're going to look at item 3 in the path list. Basically, you're going to look at sentences, and you're going to put a value called an attribute called concept onto the sentence that you're matching rules within. You're going to make a concept. You're going to put that concept as the value of an attribute called concept within the current sentence. One thing we haven't mentioned is that underscores are used for non-literals. So if something is a literal, it'll just be a number or an alphabetic. So underscores will tell you that something is a non-literal token in the language. Next slide, please. So we've talked about rule files, and the NLP Plus builds multi-pass analyzers, and each one of these passes is typically a rule file or some kind of hardwired thing, or hardwired. There are some hardwired black box passes within NLP itself. For example, looking at the top pass in the list of passes here is tokenize, and that's a hardwired. You don't get, it's not in NLP++, it's written in C++ for efficiency. So most passes are using the standard pattern matching algorithm of NLP++. If you look on the left, there's one pass that has an R attached to it. So basically, it's the same NLP++ pass file, but basically it executes repeatedly until there are no more rule matches. So basically simulating what a recursive grammar does. The pass called lines in the analyzer sequence there is actually a library pass, and there's a bunch of those, and you can build your own sets of library passes. So that one will just segment the parse tree tokens into lines, into line nodes automatically for you. So we see in the analyzer sequence, there's a pass called highlight stuff, and you can build passes to do anything you want in NLP++. So and some passes will just say, I want to highlight things that I've matched, or I want to highlight ship names, or I want to highlight anything you can think of. You can build a sequence of passes that just let you see what you've done or what you've missed. If you look at a pass that highlights all the nouns, and you're looking at the highlighted text, and you can see nouns that shouldn't have been highlighted. You can see nouns that should have been highlighted but weren't, and so on. So again, as David discussed, the whole visual aspect of the development environment is critical for doing rapid prototyping and getting things going very quickly. So the sequence on the left is kind of a typical way that I build text analyzers in VisualText. I'll start with some kind of tokenizer. Usually I actually use a tokenizer that immediately removes white space from the parse tree. And there are ways and it'll retain attributes that say a white space came before me, or a new line came before me, or tabs came before me, and you can use those attributes on the parse tree to to match rules without any white space from the outset. So it's actually a much more powerful thing in the sense you don't have to write rules with white space tokens in them. So after tokenize, I'll have a documentation pass where I'll put just some inline documentation as comments within a rule file. And then I'll have passes that with all the functions that I've written. So typically I bring in a set of pre-built passes, pre-built functions for doing like NLP utility functions, NLP Plus utility functions, and you can add your domain and task-specific functions as passes at about that place. Then I'll have an initialization pass, which I usually call ini. Down at the bottom is a fin pass, which is final actions. And, typically you'll do things like formatting, zoning. The initial tokenized pass gives you, basically will typically separate alphabetic, numeric, control characters, punctuation, but in a real analyzer, you're going to be doing all kinds of domain or task-specific tokenization beyond that. If you're parsing a programming language, you're going to say an alphabetic followed by a number, maybe it's a variable name, things of that sort. So you're going to do your own tokenizing. And the standard linguistic model is to do tokenization, lexical, syntax, semantics, and discourse. And I've kind of laid out where you might put such passes. And of course, there's no limit to the number of passes you add for any kind of capability, and for revisiting or just having multiple cycles of the same thing where you're doing the most high confidence actions first and then coming back and using those high confidence contexts to increase the confidence of subsequent actions. Next slide. David there?
Yes, it just takes time for you to see it.
Okay. So the VisualText IDE or integrated development environment, we've talked some about that, and its uses are for rapid prototyping, productization, and unlike with statistical natural language processing methods, as David had said, small data sets, small input file sets are not an obstacle to doing rapid prototyping of new analyzers. And of course, we've used VisualText to support commercial applications, visual text builders too, and we can talk about some of those tomorrow. VisualText users consist of NLP experts who can rapidly develop applications, and we find even non-experts, certainly if you know how to program in some other language, then NLP is a very simple language. And because you're dealing with English or you're dealing with language that everybody's an expert in their own language, people find they can quickly learn NLP concepts or how to program within a visual text environment. And we've shown that visual text is a force multiplier by integrating the language, the knowledge base, and all within a one-stop system. Basically, this environment seamlessly integrates everything you need to build text analysis applications. And really, it enables solving any level of complexity from, simple part of speech tagging to parsing to the most complex applications. For example, one application I'll talk about tomorrow is processing texts that have been OCR'd, which, you start with images, you convert the images to text. That process loses a lot of information. It often yields dirty text that I challenge statistical methods to process deeds and mortgages that have been OCR'd. So, next slide, please. One thing we haven't talked too much about is the structure of conceptual grammar. And really, it's not a grammar. Conceptual grammar is our name for the knowledge-based management system. So it's a simple hierarchy at its backbone, and every node in the conceptual grammar knowledge base is called the concept. Are you there?
Yeah, I'm sorry. I have my microphone. When you're at home, you have things.
Oh, okay. So the elements of the KBMS are concept, attribute, and value. And the attribute type, value types are concept, string, integer, and float. And the conceptual grammar KBMS can be mapped onto relational or other standard databases. And I've done that in the past. Just if you download the old VisualText, there's actually a version that uses a third-party relational database system to map the NLP Plus onto. The KBMS can collect information dynamically for the current text, as well as collecting information spanning multiple texts if you're processing a whole subsystem of input files and folders, which, by the way, VisualText itself supports. Within the KBMS, there's some reserved areas for efficiency and for internal use. There's a system sub-hierarchy, just things like the input file names of an analyzer might be stored there, for example. The dictionary hierarchy is specialized for efficient hashed word or lexeme lookup. Their phrase hierarchies don't come standard with NLP, with the conceptual grammar, but there are some efficient NLP Plus functions that have been built for phrase matching, and typically you don't want to hand edit any of these kinds of KBMS areas. And in fact, typically you build your knowledge bases with one analyzer and then use them with another analyzer. And I mean, it's often the case that you do mix-ins. You might have multiple analyzers that build knowledge base from authoritative sources, and so you might build an analyzer that uses one authoritative source. Then you'll transfer that knowledge base to a second analyzer that uses a second authoritative knowledge source, and so you can build arbitrarily large knowledge bases that embed all the knowledge you want to use within the application that you're building. And so the NLP Plus parse information, semantic models of the input text, and so on. Basically, any kind of modeling that you want to do, you can use the KBMS, the conceptual grammar, to store and access knowledge dynamically during a text analysis. Next slide, please.
I think we're done there.
Okay.
Yeah.
I guess we are done.
Yeah, that was good timing. I think we wanted to stop with enough, so I'll kind of wrap it up here. Today you heard about the history, NLP++, why it's become popular. Machine learning has it can go so far in NLP, and we now realize, whoops, it's doing that thing again. Now realize that knowledge-based systems are really needed, and they're turning to NLP Plus for that. It's all around the world. People are seeing this, and we're getting now people interested. And then tomorrow, to kind of round this workshop out, I'm going to do an analyzer walkthrough. I'm going to go through a particular analyzer that does quite sophisticated stuff. It is still an example analyzer. It's not a production analyzer, but you'll get a good idea to the level of which you can use this. And then Amnon's going to talk about real-world examples of NLP++. For instance, it was used to do sentiment analysis back in the early 2000s for NASDAQ, the stock exchange, NASDAQ, and other things in real estate, et cetera. And he's going to be showing real world examples of this being used. And if we have questions, you can contact us as well at david.dhilster@lexisnexusrisk.com and amnon@visualtext.org. And one thing I do want to kind of say is that it is different NLP++ because it's really not, we're used to with NLP a lot of times using plugins or machine learning or et cetera. And let me stop the recording there. But I could put my video on, I think, here. And so this is programming. That is, this is not a plugin. This is not something you would take in Python and then call from somewhere to do a certain task. We do have a full English parser that's available to do that, but this is something where you have a specific task. Most NLP real world problems are very specific. They're not a generalized problem. And when you have these specific problems, you really need to go in and program to that specific problem. And this allows us to do that. And we are only in the beginning of this because even though it's 20 years old, people are starting to realize its value. So we have probably a 10-year cycle to go in. So eventually we will have things that you can plug in and use. But really, this is at the beginning. It's quite exciting to see all these different things that are being done. So we are very happy, myself and Amnon, to having developed this technology, to see it finally 20 years later being intense interest right now. And we're here to let people know about this. I think every programmer, I'm a programmer. I started out in, believe it or not, assembly, C, C++. And C++ is one of my biggest programming languages. And I always use NLP++. I'm using constantly as a programmer in my programming job. So if you hate regex, if you have texts that are messy and you want to process those to get information out, I use it all the time. Maybe 6 to 8 times a year, I'm using it for something. And so if you're a programmer, it should really be in your back pocket as well. It's not only for NLP, it's for any kind of text. So we can open up for questions.
Questions, participants, you can just raise your hands and we will unmute.
I think there's a chat, right?
Yeah, Rutika,
I do
please
see a
ask
chat.
question.
Yeah, there is.
Okay, I did see we have a problem with the installation of NLP++ in Visual Code, where it shows an error creating an output file, and therefore we are unable to visualize the output and running analyze sequence. Most of the time when people are having problems to create, it could be simply just a writing problem, that the permissions for the directory. One of the things that's common, I find that people do, is they'll get via the NLP++ VS Code plugin. They'll go and click on the little cog, which then brings you all, like the corporate analyzer and the full English parser, and then they start working around in that. And you got to be careful, because if you work in that area, as soon as we get an update of the Visual Studio, we'll have that problem. There's also in the log area, if you look in the logging view, I have a video there, or I have some, if you click on the little 3 dots in the analyzer, the logging view, you'll see something like help for if something isn't running. One of the things you may do is you may need to go into the VS Code area where the VS Code plugin is, which is underneath your username on Windows. It's underneath .vs Code. Under that, under extensions, you'll see a Hilster NLP, and you want to get rid of the older versions. Try that. In worst case, just get rid of wipe out all your VS Code plugin and bring it in, and it probably will help. I found that that's probably it. But again, if you go to the viewing log, and I put in there these kinds of things, and this is more of a problem with VS Code than anything, that reinstalling it or the suggestions that are there. I think I put a README file in there, a couple of files that will display in VS Code as a text file. It'll tell you how to remedy it. Now, if you do have a real problem and you can't get it, you can always contact me. I can do a Zoom call with you and figure that out. But that happens.
Other questions? Actually, Kritika P, I think she'll be interning with you, David, for the summer.
Okay, no problem. I have installed another question here. If I've installed NLP++ extension VS Code, is it sufficient? Yes, it is. You can do everything with that. The thing you do want to do, and I encourage you, is to make your own area for your own analyzers. One of the things that is not apparent with the VS Code version of NLP++ is for you to start building your own analyzers. You need to create a folder somewhere in your system, especially if you're going to do it in GitHub, like you're going to back up your files, just like anything up. But it's a folder of analyzers. Each analyzer has, in NLP++, has folders that it needs. It needs a KB user folder, it needs a spec folder, it needs an input folder. These are things underneath every analyzer in NLP++. Is not a folder with just files in it. It's an organization of file folders itself. So in other words, you have to have, every analyzer has to have a place. So if you have folder, this is called, I would call it like analyzers. And then under analyzers, you'll have a folder for each of your analyzers. So when you go create an analyzer, under analyzers folder, you'll see I call it maybe my medical analyzer. You'll see a folder called medical analyzer under that. And under that folder, you have all the things that needed for each analyzer. So go to someplace on your hard drive, create an analyzers folder, and then open that up in VS Code, and then you can start creating your files. The other way you can do it, if you want to get a kickstart, I did put it, if you click on the little cog in the analyzer view, you click on that, there is a place where you can copy all of those analyzers that are part of the demonstration over to a folder of your choice. You can just say, I want to copy it over here. Once you do that, you're in a safe area. Because again, the analyzers, when you click on that little cog and you see tutorials and you see corporate, you see files, you see the full English parser, you can play around in there, but it's dangerous. The moment it's updated, it goes and updates that, so you can copy that over. So that's one way. So you go into that area, have that folder, and you can be able to build there. So yes, it's sufficient. You have everything you need there. Now NLP language. Oh, go ahead. And NLP visualizations also appeared, so I installed those extension too. Those are completely separate products. Those are for more with the kind of tools that you would download, the black boxes, quote unquote, that you would download. Some of the what people have been trying to do is make things into black boxes that are kind of have some standardization, so you can print out the visualization of a parse tree. Well, all of that's already included in NLP++. Before NLP++, people were trying to come up with kind of, a grad student would make this kind of thing, and then they make a part of speech tagger, and then they would try to make a visualization. So those things are not part of NLP++ at all. And in fact, you don't need them, because the tree structures and display in the VS Code, NLP++ VS Code, are way better, because you can see, not only do you see them build, as you build the tree, you see it, you can write rules, all that kind of stuff. So none of those are associated with NLP++, and everything you need is all there. Another question is, No problem. Another question is NLP++ similar to expert systems and AI? Did you want to take that question, Amnon? It's really, or did you want me to answer? It doesn't matter. It's up to you.
Go ahead. I think
Okay.
you can do it.
Okay, so yeah, what we have is a conceptual grammar. And conceptual grammar basically can put any human knowledge you want in it. And yes, we can do what expert systems. In fact, we do those similar things. In fact, we have confidence values, which part of the old expert systems, paradigm. And what we do now is, for instance, I'll give you an example. One of the things we have in medical codes, there are 37,000 medical codes in the United States. When you read a text, you have to know that medical code, and you say it's code literally 55AB9. Well, to do these, you have to look at all the possible codes. You then maybe put a confidence on those. You read this text and think, well, I'm talking about the lung, I'm talking about the left lung, I'm talking about this disease, this bacteria. And then when you look at it, you then make some knowledge base of the text, what you found. You put in a confidence value, and then you have to choose among that. It's very similar to expert systems. You have all these kinds of inputs. You make some logic. You get some logic. You then have to make some logical decision based on the configuration of knowledge you have for a particular text. And so, yes, you can build an entire expert system, the old-fashioned back in the 1980s, 1990s expert systems kind of stuff in NLP++. You can write NLP++ without ever looking at text. You could only do a knowledge-based system. You wouldn't have to, you could do that. You could suck in a database, put it into a knowledge base, do some expert knowledge on that, and then come out with the answer. So
Well, you have to process a dummy text.
Yeah, you can do
This
that.
is a dummy text.
Yeah,
but you don't have to do anything with that text.
But yeah, you can do it that way. So
yeah,
okay.
But I mean, more generally, I mean, NLP++ is a programming language. VisualText is a development environment. So, yeah, you can use it for expert system-like things, but really, we're talking about. I mean, it's a general programming environment, and with specializations for natural language processing and such applications.
Right.
And many more, as David says.
Okay.
Any other questions?
Oh, access to these slides? Yes. After tomorrow's talk, we will give you access to the slides. We'll give them to Dr. Shoba. We'll also put them anywhere else that we feel that you may want to take a look at them. I think it's a really good background. We also do have video.
Yeah. Sorry, can
Yes,
you mail us today this slides so that we can share it with the participants?
Yes, we can do that. Yeah, we can do that. And we also do, remember, we do have a YouTube channel where we do talk in depth about a lot of things. And do remember, we are in the beginnings. This is an area that's not exploding, but it is growing quite a lot. And so we are open to helping out at a one-on-one level with anything that you're doing. You can contact myself or Amnon. If there's something that you see that you don't understand, we can oftentimes make a YouTube video about it. But we are available. You can contact us through visualtext.org, the website, the open source, and of course we have our GitHub as well. The question is,
I mean, it's new. It's only 23-year-old technology, David. It's very new.
But it's now, the technology is always, one of the things is, I saw a TED Talk on technology, and the number one thing that they found out why technology works, it's the right technology at the right time. We were ahead of our time with this, and now people are wanting to do this. They realize that statistical neural networks, machine learning can't do it. And so that's what we're looking at. And the answer to the question, is there any textbook? The answer is, Amnon should be writing this textbook. We've wanted to do this for quite a long time. We've even, I don't know if you have all those textbooks. Which one of those textbooks that have the animals and like
Riley? The
The
Riley
Riley.
books.
Yeah, we're looking to hopefully eventually write a Riley book for NLP++. But if you go to the tutorials, I do kind of step through things. I even talk about the variables, and you can walk along in a tutorial with NLP++ visual extension in VS Code, follow along. So there's quite a lot. The tutorials do help on the language aspect of it because it is a different way of thinking. It really is.
So I would say, historically, NLP++ developed as an action language for pattern matching. I mean, the whole language evolved bottom up, and there's no language committee, there's no formalization of the language. These are things that have yet to be done. So.
But we keep augmenting it. That is,
Exactly.
You can see the versions as if you're using it, you're going to see it, not recently because I've been so busy, but we will constantly deal with issues. If you find a problem with it, you can put those issues. If you find functions, I've added at least half a dozen new functions to the language itself. So yeah, those are things as it's being used is something that we can add. Oh, here's another question. What can be a simple application that one can start with to realize its power? Good question. I think one of the areas you can do is to simply take, this is a good one. A simple one that I do all the time, and it shows you its power. Go to a web page where you have information that's interesting. He'll give you an example of one I did, and it's in the dictionary now. I went to the United States Postal Service and all the abbreviations for roads, circle, lane, drive, all those things. And I looked at the HTML. Go look at the HTML. It's really hard. Go write an HTML parser for it. It's going to probably fail because they've got so much, as we all know. The amount of code behind an HTML page can be ridiculous. It can be just absurd. It'd be impossible to parse. What I do is I'll go to that page with the text, literally with my mouse, go to a page where you have really good information, like the languages of the world. I went to this, go to the languages of the world. I cut and paste that, and there I got a text file, and it was kind of messy. It wasn't perfect, but I could see the information. It was like on every line. And then you can write a parser to parse that information, put it into a dictionary, a .dic file, and that's what I did. I have that for the resume file. I could actually maybe make a YouTube tutorial on that. So I went to that hundreds page. It's in part of this. I can make that visible. And then I wrote a parser in about half an hour, maybe less, 15 minutes to half an hour. I wrote a parser to grab that information, and now I have a dictionary of all the languages, the top 100 languages spoken for resume processing, with not only that, all kinds of information, and that's what I did. I did the states. I did the same thing. The states of the United States. I went to a web page, saw the states of the United States. It had all kinds. And actually, I used a Python script to go and get the web versions of every state, and then I put them in a folder, and I processed those all to make a knowledge base of all the states. In fact, I don't know if that's available yet, but that's supposed to be available. So go to some web page where you have some really great information. That's really, what are you going to use? Regex?
Find something that's of interest to you and that you want to get information from. Something that'll be useful to you.
Right.
That's where you're motivated.
We're hoping with time that everybody with this project, I call it the NLP Global Initiative, because NLP Plus now gives us the glue for NLP doing it. Everybody can use the same thing, that we can go and build the dictionaries, knowledge bases, so you don't have to do that. Right now, you don't have to go get the stop words in Chinese or in English. You just go pick them up, put them in there, run a text on it, and it'll mark all the stop words, all these kinds of things. So that would be my, and you'll see how powerful that is. You'll quickly see, because you're going to think about the students. I know Dr. Shoba, they sat around and they said, what if we had to do this Wiktionary process? You got to go to Wiktionary and process these things. What language would we use? I think you come to the conclusion, well, it's very easy with this technology, this NLP++, but doing it somewhat with something else like Python, you have to come up with systems to do it. where would you do that? You'd have to build something to do the tasks. So hope that answers that.
One more
yeah.
question. Share your
Yeah, there's another one. It says share your YouTube links talks. Just go to this, I'll type it in. Just go to VisualText.org, and there you will be able to find the YouTube there. Just click on the menus up there, and you can go there. And there's if you search for VisualText NLP in YouTube, it should get to the VisualText channel, the NLP. You'll see the NLP Plus logo, which is NLP Plus, and you'll be able to see there. I also gave a really nice talk at Clemson University. If you want the bigger picture of why this technology is really, people are really excited about this now and why they see it used for it. I think we're done with our time.
Yes,
is that right,
yes.
Shobha?
Yes, David, it is time for the today. And thank you so much, David and Amnon, for giving the NLP Plus overview, and also the difference between traditional language and NLP Plus is extensibility, then file structures, then variables. And to start with the basic ideas of NLP Plus, I hope the participants would have got. And tomorrow, with the case study and little more extra features of NLP Plus may make the participant more interesting to work with NLP Plus programming language. Thank you once again for your nice talk. And thank you, participants, for your patience here. Thank you so much.
Thank you for the opportunity.
Yeah, thank you so much.
Our pleasure.
Thank you.
Yeah, our pleasure.
Okay.
Yeah, we'll meet tomorrow, sir.
Okay.
Yeah. Thank you. Thank you all.
Okay.
Okay. Bye-bye.
Good.
Bye-bye.